So the last video focused primarily on square root functions, and at the end I briefly talked about cube root functions. So this video is going to talk just about cube root functions and the different transformations that you can apply to a cube root function, just like you apply to a square root function. So again, cube root function is just a radical function with an index of 3 instead of an index of 2. But the graph of a cube root function is different than the graph of a square root function. So the graph of a cube root function is this S-shaped curve. So again, that parent function has a point at 0, 0. And if you look, it does follow a similar pattern of up 1 over 1 and then down 1 over 1, just like the square root function did. But now you have the two portions of it, not just the 1/2. So when your parent function is a cube root of x, and what's special about cube root function is that your domain and your range are all real numbers all the time. So you don't have to worry about trying to figure out the domain and range of a cube root function because no matter what, it's always going to be all real numbers. And yes, you have this S-shaped curve. And again, when you're graphing and you're looking at the different graphs of the cube root function, you're primarily focusing on that middle point and these other two. And then from there, it's just kind of a sketch and an estimation of what the graph would look like. And all the different transformations really just apply to this point here. So looking at this example, so what we're going to look at is the cube root of x minus 4. So again, all you're doing is taking that S-shaped curve and translating it down 4 units, and everything else stays the same. Now, if you reflect it, reflecting it over your x-axis would just flip it. So instead of starting in the lower left and going up to the right, you're starting in the top left and going down to the right, making that S-shaped curve. So that's what the negative would be. So you're reflecting it. So up here would go down there, and then the downwards part down here would come up here. And when you have a +2 inside, remember that's really to the left 2. So that's why that center point moved over 2 units. So again, you got to be careful about the units for the graph. This is technically over 2. And then another example which applies multiple transformations. So you have a vertical stretch to the right 3 and up 4. So if you notice here, we're really going up 1 over 1, as I said before, but because you're multiplying by 2, you're going up 2 over 1. Just like with the cube root function, you're going to multiply by 2, and then up 2 over 1, up 2 over, I think it's like 8. It's not 3 anymore, because it's a cube root function instead of a square root function, so it's slightly different, but still you're going up 2, then over. So your starting point at that 0, 0 should be going to the right 3 and up 4. And look, 0, 0, up 1, 2, 3, up 1, 2, 3, 4. And that's where your middle part, or where your change in direction occurs. So cube root function, all the same transformations still apply, except now you have an S-shaped curve instead of just the opening upwards of the half quadratic like in a square root. So again, these are mainly sketches. You don't have too many points on these graphs. The one that's primarily the focus is that middle point there, and then 1 or 2 to the side. And that is all for cube root functions. Again, cube root functions, very, very similar to square root functions. You just have a different shape of your graph.